Hey guys, you are welcome to our class. We are still on gas laws, and previously we talked about pressure. So today we'll be looking at pressure measurements. That okay? We are going to be looking at pressure measurements. So as I've always said, please get your writing materials ready so that we can go straight to our class. This is Nobleman Science Tutors Online, and I remain Otobo Michael. You can reach us through the WhatsApp number that's showing on your screen. And please, guys, if you have not subscribed to this channel, please subscribe to our channel. Click on the notification bell so that when we upload a new video, YouTube will notify you. Alright, so I hope you are ready, and so that we don't waste too much of time, let's go straight to our class for today. As I've said, we are looking at pressure measurement. Pressure measurement, right? Okay, so in our previous class we discussed that pressure is equals to force all over area. Now the instrument for pressure measurement is in the laboratory. Mostly it is a manometer that is used, and if you visited your lab or from your test, you see that the manometer actually has this shape, and the way it is connected is that you have a gas that is connected to one arm, then the another arm is open to the atmosphere. Right, the other arm is open to the atmosphere. So this is how actually it is connected. Now for you to measure, a manometer can either contain water or mercury, as the case may be. Right, so one end of it is connected to the supply of gas, and then the other end is exposed to the atmosphere. Right, the other end is exposed to the atmosphere. So like for this diagram one here, you see that the manometer is one end is connected to the gas while the other end is closed. So because the other end is closed, the pressure on this particular the pressure of this gas is just the pressure that the gas exerts on whatever liquid that is here, and that is what is given to you as a density times height times g. That okay, don't forget, this is height, this is density, and this is acceleration due to gravity. Remember that in our first video we have already discussed this particular equation. So in this particular instance, there's no atmospheric pressure because the one end of it is closed. So in this particular instance, no atmospheric pressure is acting here. Okay, so when you come to this particular B, you see that yes, this end is open to the atmosphere. The end is open to atmosphere. So in this particular instance, because in this particular instance, the height, there's some gas still left at this point X, and this height of atmosphere, the effect of the atmosphere or the difference in height is at this level. The pressure of the gas here is equals to atmospheric pressure minus this difference in height, and that is what you have here. Atmospheric pressure minus the pressure due to this particular height, right? Atmospheric pressure minus the pressure due to this particular height. Then for this particular, for diagram C, you see that the height of the mercury on the arm that the atmospheric pressure is acting is lower than the height of mercury on the arm that the gas is acting on. So here the pressure of the gas is equal to the pressure due to the atmosphere plus the pressure due to the difference in height. So I decided to bring this particular diagram out and make it clearer in this particular place. So this is what this diagram actually represents, and that's what I brought here. So the pressure of this gas equals to the pressure of the atmosphere plus the pressure due to this particular height. Is that okay? So, and that is what we have: atmospheric pressure plus the pressure to this side is H through G, which is P plus H, right? Now, for this particular one, the B part, you see that the height of the mercury on this particular arm is um is lower, is lower. So the pressure is acting down to this particular point, and that's what we have here. So that is why the atmospheric pressure, or the pressure of the gas, equals to atmospheric pressure minus the pressure of the difference of that height, or the pressure due to this particular height. All right. So this is how, these are actually, these equations you have here, these are the equations that you can use to solve for pressure, depending on what the equation is asking you to look for, depending on the variables that you are given. So please take note of this, so that when you want to solve problems, you know which and which we are using. Is that okay? So having done this, we are going to solve some problems now, just to drive on further understanding of what we just discussed now. Right, so let's look at some problems immediately. Okay, look at this question, and this is the diagram of it. See, what is the gas pressure in the setup below if the atmospheric pressure is 760 millimeter Hg? And this is actually a jam question. So please, whenever you see a question like this, they are as easy as anything, because you know in jam you are saving time now, and these are some of the questions that they bring. This is actually a past jam question. Is that okay? So what you need to do here is that if you just go back to what I just discussed now, here you are given atmospheric pressure. You have given atmospheric pressure to be 760 millimeter Hg. Okay, so atmospheric pressure is given to you to be, atmospheric pressure is equals to 760 millimeter Hg. Sorry about that. Please just pardon me for that. So, and this is also equals to, remember that if you divide this one by 10, if you convert it to centimeters, so this equals to 27. You try so that all your units will be uniform. Okay, so this can also be written as 76 centimeter Hg. Fine. Now what you need to look for now is the difference in height of mercury. So difference in height of mercury is equals to difference in height of mercury on the two arm. Is equals to 15 centimeter minus 4.5 centimeters. So if you, so that will give us 10.5 centimeters. Okay, so you try so that all your units will be uniform. That's why I converted this to centimeters. So here is the unit I gave here, they are in centimeters. So the pressure, the atmospheric pressure, I have to convert it to centimeters. So that gives me this and that. All right. So having gotten this, we said that the pressure of the gas, P gas, is equals to atmospheric pressure plus pressure due to height of mercury plus H. That's what we said. Okay, so substitute into this equation, you have that pressure of gas would now be equals to 76 centimeters plus 10.5. Okay, so just add that up. When you add that up, you are going to get you are going to have 86. You have 86.5 centimeter mercury. So that is the pressure of the gas. You can equally convert this to centimeter by multiplying it by 10. If I mean to millimeter by multiplying it by 10, if you convert it to millimeter, you're going to have this times 10. Let's convert it to millimeters. So you have 86. you have 86.5 multiplied by 10. So that will give you 865 millimeter Hg, as the case may be. Okay, so the questions on this particular topic, they are really very simple. So whenever you see a diagram like this, please don't be afraid, just follow these steps and you just have your answers readily, right? Okay, so this is another one. This one says when one arm of a U-tube manometer is connected to a gas supply, the levels of mercury in the two arms of the U-tube are as shown in the diagram below. If the atmospheric pressure is 76.0 centimeter Hg, what is the gas pressure? So this one is just like the one we did before. Okay, so gas pressure P gas is equals to P atmosphere plus H, right? So P atmosphere has been given to you to be P atmosphere has been given to you to be 76 centimeter Hg, right? Then height of mercury is difference in height. So difference in height is equals to 13.4 minus 3.5. Okay, so because this is the difference in height, the difference between this and this other one. So that gives you, when you do that subtraction, it'll give you 10 points. That will give you 9.9 centimeters. 9.9 centimeters. So pressure, gas pressure will now be equal to, substitute to this formula, you add that P gas is equals to 76.0 plus 9.9. So when you work that out, you will have 85.9 centimeters Hg as your gas pressure. Then you can convert it to millimeters by multiplying by 10. So that will give you 859 millimeter Hg of gas pressure. So P gas is equals to that. Okay, so I hope these questions are simple, so that when you see them in your textbook or in your past questions, you should be able to tackle them, right? Fine. Okay, so right now we are going to start to discuss the gas laws. We've talked about pressure, we've talked about the pressure measurement, but what about the gas laws? So we'll now start with Boyle's law. Okay, so Boyle's law states that the pressure of a fixed mass of gas is inversely proportional to its volume provided temperature remains constant. So I'm sure you are familiar with this particular definition, and mathematically stated pressure is inversely proportional to volume, and then so you have this constant of proportionality, right? So this can be converted into this equation. So when you take the constant of proportionality, you are looking at a particular gas that is expanding from one volume to another, then you can now have this relationship of this equation that P1 V1 for the initial pressure of the gas, and then P2 is equals to P2 for the final pressure and final volume of the gas. So depending on what you are looking for, you can actually have equations or questions that would make you to solve for any of these variable that is not given. Okay, so this is actually the equation for the Boyle's law. This is the equation for the Boyle's law, right? So we're going to look at some problems straight away. so that we can also solve some questions on this Boyle's law. Okay, so this is Boyle's law equation. So a fixed mass of gas at a pressure of 650 millimeter Hg occupies a volume of 20 centimeter cube. What will be the volume of the gas at 760 millimeter Hg if the temperature is constant? Okay, so we know that when you increase the pressure on a gas, the volume will decrease. So that's okay, the volume will decrease. Okay, so let us bring out the variable that are given to us. I'll be giving that P1. In this case, P1 is given to us to be 650 millimeter Hg at V1 is given to us to be 30 centimeter cube. P2 is given to us, P2 is given to us to be 760 millimeter Hg, and V2 is unknown. V2 is unknown. Okay, so from that formula, from P1 V1 is equals to P2 V2, we can now make V2 the subject of the formula. If we make V2 the subject of the formula, we're going to have P1 V1 all over P2. Okay, so substitute now what you have into this formula. This will give us 650, sorry, let me wipe that and write it properly. So you have 650 times 30 all over 760. So please punch this out in your calculators. If you punch this out in your calculator, you're gonna have V2 will be equals to 25.66 centimeters cube. Okay, so I think this is relatively simple for you to solve. You have 25.66 centimeter cube. So like I said before, you see that when the pressure is increased, the volume decreases. So when you increase the pressure to 760 millimeter Hg, the volume has decreased to 25.66 centimeter cube. Okay, so I hope you can relate easily with this, especially with this equation. Okay, so let's solve another problem still on this pressure. Okay, so this one says that a gas at a volume VO, that is initial volume, in a container at pressure PO, initial pressure, is compressed to 1/5 of its initial volume. Calculate the new pressure if the temperature remains constant. This is a jam question. Okay, so this is a jam question. Alright, so from this problem, you are given that V1 is equals to VO. You are giving P1 to be equals to PO, and you are giving V2 to be 1/5 of VO, because to say 1/5 of initial volume. Okay, so P2 is what you are asked to find. Okay, so from your P1 V1 equals to P2 V2, you have that P2 will be equals to what? P1 V1 all over V2. So substitute all the informations you have into this equation. You are going to have that P1 is PO multiplied by VO all over V2 is equals to what? Is equals to VO all over 5. So I think this is simple mathematics. So this one you can rearrange it. If you do rearrangement, right? If you do rearrangement, you are going to have you will have that VO, you have that PO multiplied by VO all over VO multiplied by 5 all over 1, so that this will cancel out. Then finally you are going to have that this will be equals to 5PO. So P2 will be now equals to 5PO. Right, so what this simply means is that if you compress a gas to 1/5 of its initial volume, the pressure will increase 5 times of its initial pressure. Is that okay? So when you compress a gas to 1/5 of its initial volume, the pressure will increase 5 times of its initial pressure, right? So that is what this simply means. I hope this is simple and easy for you to comprehend, right? This is simple mathematics. Okay, so that is it, and I hope it's clear for you to understand. Please solve more problems from your textbook and from some past question papers. Beside that, please go through these questions. This test your understanding page. Go through these questions and try to solve them. If its mass of gas occupies the volume of this at this, assume that the temperature remains constant, what will be the volume of the gas? We've solved this before. Then when the pressure of a fixed mass of gas is doubled at constant temperature, the volume of the gas is what? Solve this problem just like the one we solved just now. Then you get these are jam questions. Okay, so thank you so much guys for your time. This way we're going to stop for this class for now, but please, if you have not subscribed to this channel, what are you waiting for? Subscribe to this channel, give us a thumbs up, give us a like, give us a positive comment, so that we will continue to bring out quality and educative videos in physics. This is Noble Mind Science Tutors Online, and I remain Otobo Michael. You can reach us through the WhatsApp number that is showing on your screen, and then please give us a thumbs up. Okay, you can also invite your friends to come and enjoy this video and this wonderful class that you are enjoying. Continue to read your books so that you can become a better you. Right, so thanks so much. I'll see you in our next class. Thanks.